All right, guys, so you should have already done your review for multiplication, and you'll see why that's so important. If you can go ahead and title, make sure you're keeping up with your numberings. But this is going to be in our quadratics unit. And we're going to be talking about solving by factoring. So there's a lot of different ways to solve, but we're going to start with the simplest one. When we factor something, the first thing we want to do so you can only solve, first of all, if there's an equation, which means there must be an equal sign. Then what we want to do is we want to be able to take this and break this into pieces. Now it has to equal 0, or we have to make it equal 0, which we'll talk about on a more advanced one. But our first step is always going to be GCF, which just means greatest common factor. Now here, these numbers in front, they're not showing me. If they don't tell me, it's an implied 1. So there's a 1 here and a 1 here. And since it's prime, we can't GCF. Our next step is to multiply A to C. Now you need to remember every time it's quadratic, it's always going to be AX plus BX plus C equals 0. I forgot my squared. Let me put the squared on that. AX squared plus BX plus C. So here we're going to take the 1, multiply it to the 42. Your third step is to set up a big fat X. So I'm going to just do this right here. A and C are going to go here, so negative 42, and B is going to go here. Now it doesn't really matter. We just know that this is going to be multiply, and this is going to be add. Step 4 is you have to find your factors. Whatever is going to go here and here have to multiply to negative 42 and add to negative 1. So if I do 6 and 7, those multiply to positive 42 and they would add to 13. So I can make either one of these negative and it would make this negative. But I need 7 to be negative so that when I add it together, I get negative 7. I'm sorry, negative 1. So the negative goes on the 7. Now if I multiply those two, I get negative 42. If I add them, I get negative 1. I'm just going to set up your parentheses. Let me zoom that in. So now that we have our factors, it's just going to be n plus 6, n minus 7. Now this should be a review from Algebra 1, but that was a while ago. So these are my factors. So this is a factor, and this is a factor. Now if you think about it, we want these, when these multiply, we have to get 0 out. So think of any two numbers in the entire world. The only way you get 0 is if one of them was 0. So we're going to set each factor equal to 0. So n plus 6 equals 0, and n minus 7 equals 0. I'm going to have two equations. Now I'm going to have as many equations as whatever my highest power is. If that was a 3, I would have 3 equations. If that was a 4, I'd have 4 equations. Now realistically, you only know how to solve a power of 2 and special cases of powers of 3s and 4s, which we'll go over. So what we have, we're just going to solve. I want the n by itself. So take away 6, take away 6, n equals negative 6. Add 7, n equals 7. That's pretty much it. Let's go through some special cases. What if we gave you r squared take away 36? Now there's still an invisible 1 in front. The trickiest part here is you don't have your b term. Remember, a is with the x squared, b is with just a plain x, and c is just the number. So I have my r squared term. So this is going to be 1 times negative 36. But my b is 0. And that's okay. We're just going to have negative 6 and positive 6. This is called a difference of 2 squares. And very simple. Everything's the same still. R take away 6, r plus 6. Set each factor equal to 0 and solve. R minus 6 equals 0, r plus 6 equals 0, plus 6 minus 6. R equals positive 6, r equals negative 6. Let's get into a couple trickier ones. What if they gave you you can see there's no c term. So I've got my b squared, my b, but I don't have just constant. So this, in this case, our only thing that we can do is GCF. I can take a b out of both of those. You should be able to see that if I multiplied those back, I would get back to there. And then just like always, set each factor equal to 0. So I've got 1 already. Man, that's a bad 3. Try again. And I've got my 2 factors. Whatever that is, that's how many I have. It's okay if they repeat. Let's go through a slightly harder one. All right, let's go through what happens when you have a number besides 1 as your leading coefficient. So I've got that 3 there. Again, I'm going to GCF. I cannot. This is prime, and that doesn't have any common factors with 3 and 5. So that I can't do anything else. So step 2, I'm going to take A multiply to C. $15 goes here, negative 8 goes here. Step 3 was set up your big fat X. Step 4, we're going to factor. Find factors. Now, please write down that this is what you need to multiply to, and this is what they have to add to. So 15, I can do 1 and 15, but there's no way for those to add to 8. But 3 and 5, those add to positive 8. Since I want it to be negative, they both have to switch. So those are both negative, add to negative 8, multiply to positive 15. Now, on the other one, we didn't have to do the next step. We're going to set this up. M take away 3, M take away 5. Whatever's here just comes down to there. This step put up your parentheses. We have one more step here. Divide each factor by A. What I mean by this is since we multiplied by 3, we have to divide these numbers by 3. I'm going to divide by 3. I'm going to divide by 3. This one goes in nicely. Reduce it. This one doesn't, and you're usually going to have one that doesn't. Just put it in front. That's it for your factors. Here are some things to know. Reduce if possible. If you can't reduce, put the denominator in front. Now this has worked for me for, I want to say 20-something years. I've used it through multiple levels of calculus. Works every time. And those are my factors, and now I keep going. I'm going to just set each factor. Equal to 0. So m take away 1 is 0. 3m minus 5 is 0. Plus 1, plus 1, plus 5. Divide by 3. I've got my two factors, and we're done. I guess 8 would be solved. Let's do another one. Let me see if I can get you one that is a little more interesting. Yeah, let's do that one. That's a big number. All right. Now again, remember, whatever numbers in front, I try to factor out if I can, but I can't. So I multiply these two. Now, you can use a calculator, but honestly, I'm too lazy. I don't even multiply them. I leave it as 21 times negative 10. I changed it to parentheses because I had a negative. And I want this to be a 1. Remember, if they don't tell me what's in front, it's a 1. So we want things that multiply to this. We want them to add to these. So let's think. 12 and 10 are too far apart from each other. So I'm going to think of numbers. 21 I can do 3 times 7. 10, I can do 2, and I can do 5. I'm going to try to regroup these. What about 7 and 2, which would be 14, and 3 and 5, which would be 15. Now, just to help you understand what I'm doing, I'm just breaking these down into their primes. So 21, right, that's where this came from, and this came from 10. Now, once I have those prime numbers, I can rearrange them as much as I want, and as long as they're multiplied, it's still going to give me the same number. So I'm thinking we're going to do 14 on one, 15 on the other, and I want the 14 to be negative, so that when I put these two together, I get a positive 1. And then just because it's big numbers, let me show you. Oh, it's thinking very hard. So what we're going to do here is just 21 times 10, 210, easy. 14 times 15, 210. 3 times 7 times 2 times 5, oh, 210. So just helping you really understand that these numbers, I can use any grouping I want. Now, remember that was a negative, so negative 14 times 15, negative 210. Now, what if I added those? Positive 1. We're good to go. So the next thing we're going to do is I'm going to do my factor, set up my groups. And then remember, since we multiplied by a number, we're going to divide by that same number. If you can reduce, you do. I can take a 7 out of both of these. So I'm going to take a 7 out of 14, which would leave a 2. 7 out of 21, which would leave a 3. I'm going to take a 3 out of both of these, which would leave a 5 and a 7. Now remember, since we, if it doesn't go in perfectly, this number goes in front. And then we're just going to set each factor to 0. And this factor equal to 0. Make sure you can tell the difference between a negative and your equal sign. Two things I'd like you to see. One, I'm hoping you see that these are basically the same numbers, they just flipped the sign. The reason I'm making you do this, I'm going to show you why. If I take 3v minus 2, 7v plus 5, when I multiply this back out, I have to get back to my original question, or they're not equal. If I took this and multiplied this out, v minus 2 over 3, v plus 5 over 7, they are not equal. I'm going to multiply real quick. That would be a v squared plus 5 over 7v. Having a hard time. The camera is in the way for writing. Minus 2 over 3v minus 10 over 21. Without even simplifying, I already know that this is not going to equal that. It's just not, there's no way for me to get 21 from 1. So what we're going to do is if I do this again, 21v squared plus 15v minus 14v minus 10. Notice that those numbers are the same numbers that we're using in our factors. When those go together, back to where we started from. And that's why it works. Now when you're showing your work, I want you to at least show me that you know it's supposed to go in front, and then I don't care if you jump to here and switch the sign, that's fine. But I want you to practice putting it back in front. That's all, guys. Good luck. Make sure you're showing your work. Make sure you're numbering your pages. This is your notes, so let's make sure we put our notes. And make sure in your journal on the next page, you're going to name it the same thing, Quadratics Solving by Factoring, but instead of notes, it's going to be assignment. So Quadratics Solving by Factoring. Your assignment's in CUDA, and I'm just looking mainly for your effort. If you get stuck, let me know. I will try to help you. Good luck, you guys.